friends. So welcome to QX Tutorials. This is Mahesh. So in this video, we'll discuss about the synchronized access modifier and the synchronized block in Java. So till now we discussed different access modifiers in Java. If you see this table, so we covered up to now the synchronized access modifier. We discussed about public, private, protected, default, static, abstract, final, and the native access modifiers. So if we see the synchronized access modifier, this synchronized access modifier is applicable only for the method. So we cannot apply the synchronized modifier for a class or a constructor or an interface. Okay, so this access modifier is applicable only for the method. So first I'll list out the points about the synchronized access modifier. Then I'll try to justify these statements with an example. Okay. So the definition for synchronized access modifier is, so synchronized is one of the access modifier. Synchronized is one of the access modifier which is applicable for methods. Okay, so it is not applicable for the class or constructor or for variables. It is applicable only for the methods. Okay. Why we need this synchronized access modifier? So why we need this synchronized access modifier is to acquire a lock on the object. So if you see the definition or why we need the synchronized access modifier is, so it is used to acquire a lock on the object, when thread is accessing a specific method. So this is the purpose of what? The synchronized access modifier. So synchronized access modifier which is used to acquire a lock on the object when the thread is accessing a specific method. So what is the advantage what is the benefit you will get by acquiring a lock on the object is, so only one thread can access the object method at a time. Only one thread can access the object method at a time. If other thread try to access, at the same time, it will be in a waiting state. Okay, so assume that there are two threads. The two threads are trying to access the same object method, but you don't want to allow the both threads to access that method at the same time. So at that time, what we'll do is we'll apply that method as a synchronized modifier, so that what will happen is only one thread can access that method at a time. Okay, so this is the benefit you will get by applying the method with the synchronized access modifier. Okay, so if you see the syntax, for the synchronized access modifier, so we'll declare the method with synchronized access modifier. Then after that specify the return type of the method. So then we'll specify the method name, and you can specify the parameters for the method. Okay, so this is the basic syntax of creating the synchronized method. Okay, so you can specify before this public or private or protected. Okay, so then after that we can specify, or if we don't specify anything, it will be the default, right? So then after that, synchronized access modifier, then after that specify the return type and method name. This is the syntax of creating a synchronized method. Next, if all the methods of a class, is applied with synchronized modifier, so that class is called as thread safe class. Okay, so if any class methods are applied with the synchronized access modifier, that class we will be call it as a thread safe class. For example, uh, in java.lang package, java p java.lang. We have a class called string buffer. Okay, so if you see this string buffer class, all the methods of this string buffer, you can see the append method, synchronized. So forget about this. The first four are the constructor, it's not methods. Okay, then after that you can see all these methods, length method, capacity, trim to size, all these methods are applied with synchronized access modifier. So that's why we call this string buffer class as a thread safe class. Okay, so the example for this thread safe class is java.lang.string buffer. Okay, so this is about the synchronized access modifier. Okay, so we'll see with an example, but before that, theoretically, just I listed the statements about this synchronized access modifier. Next, we'll see diagrammatically, we'll see what exactly the purpose of what the synchronized access modifier. Okay, so the previous videos I explained. So whenever you run this application, so JVM will load into RAM for execution, right? So the JVM will load into RAM for execution. So inside the JVM, we have different memory units, right? We have different memory units. So we have a stack and we have heap, like that. We have different memory units we have. So, and you know that the objects will be created under the heap. The objects will be stored inside the heap memory. So here inside the JVM, so there will be a memory unit called heap. Okay, so assume that inside the heap there is an object. Okay, inside the heap. Okay, assume that it's an object. I'll give some name for this object called bus. Okay, so I'm taking an object. Assume that this object I'm taking for a bus. Okay, so in this bus, okay, the bus will have some properties, right? Like what is a bus number from to, like that. So inside this bus object there is a function called book ticket. Okay, inside this bus object there is a function called book ticket, so which will take what is the seat number. Okay, so I mean, to book the ticket you need to pass these parameters: what is a name, what is a seat number, and what is your gender. So you need to pass these parameters to book a ticket. Okay, so assume that there is an object. We give a name for this object called bus. In this bus object there is a function called book ticket, or there is a method called book ticket. Okay, so in the previous examples I told each and every whenever you run this program, each and every main method will be loaded into stack for execution. Basically the main method, whenever you run the main method, so actually it's going to create a thread. So they'll call it as a main thread. Okay, so inside the stack, so same like heap, we have another memory unit called stack. And in the previous sessions I told, whenever you run this program main method, so it's going to load the stack into, it's going to load the main method into stack for execution. But basically what will happen is inside the JVM we have a separate memory unit called stack. Okay, so inside the stack, how many threads you created? Okay, so memory is going to be allocated for the threads inside the stack. So assume that there is a main method. For main, it's going to create a separate thread called main thread. Okay, whenever you run this main method, so it's going to create one thread called main thread. Okay, so next, if you want, you can create two more thread. I mean, if you want, you can create a number of threads you can create. In Java, we can create a thread by extending a class called thread class. We can create a separate thread we can create. Okay, assume that here I'm creating two separate threads I'm creating. So one thread I'm giving a name as Abhibus. Abhibus is the name I'm giving for one thread. Okay, the another thread I'm giving a name called redbus. Okay, so assume this redbus and Abhibus both are accessing, these are two separate threads. Okay, so assume this Abhibus and redbus are two separate threads. Let's take thread 1 and thread 2. Thread 1 and thread 2. Okay, so both these threads are accessing the same method. Assume that both threads are accessing the same method and the same seat. Assume that the both threads are accessing the same method and the same seat. They are trying to book the same ticket they are trying to book. So at that time what will happen is some conflict will occur here, because it's going to book the tickets for both. I mean, the Abhibus, one ticket will be booked through Abhibus and one more ticket will be booked through Redbus. So correct or not? So here some conflict will occur, and whenever if these two passenger go to bus, so at that time we can see a big fight, right? They'll say, one passenger will say the ticket is confirmed to me, another passenger will say the same seat is confirmed to me, right? So here this is the conflict you'll get. So here two threads are accessing the same object. See, if its object is different, it's a no problem. Okay, here when the problem will come is two or more threads are accessing the same object method. At that time the conflict will come. If there are two different multiple objects, then there is no issue. Okay, if two or more threads are trying to access the same object method, then there will be some conflicts will occur here. So what is the solution for this problem is, so here apply this method, whatever the method you created. So apply this method with the synchronized access modifier, so that what will happen is, which thread is called this method. Assume that first Abhibus is called this method first. Assume that first Abhibus is called this method. So which thread is called this method, a lock will be acquired for that thread. Which thread is called this method, so for that particular thread a lock will be acquired on this object, so that what will happen is, if second thread try to access this method, it will be in a waiting state. Okay, so it will be in a waiting state. So when the thread 2 will access this method, is once the lock is released. So when the lock will be released is after execution of this method. See, thread 1 is done, completed its logic, it's executed that method. So then what will happen is the lock will be released. So whenever the lock is released, so another thread, I mean which thread is in a waiting state, that thread can access that method. So this is diagrammatically, I explained the synchronized access modifier. So what is the purpose of synchronized access modifier, and what will happen if you apply the synchronized access modifier. So now we'll see the same example, whatever we discussed. Programmatically, we'll see an example. We'll create two separate threads. We'll create, and I'll not discuss more about the threads in this example, because my intention in this video is to give a knowledge on the synchronized, not on the threads. Okay, so that's why I'll not explain much about the threads, how to create a thread and how to start the thread and all in this video. Okay, in this video, the focus is on synchronized access modifier. About the threads, I'll make a video on the, okay, in the next coming days, I'll make a video on the threads concept. Okay, so as of now, just understand how to create a thread. To create a thread, we need to create a class which extends the thread class, and the thread class will contain a method called run method. So you need to override that run method, and that run method cannot be called explicitly. We cannot call that run method. So that run method will be called whenever you start the thread. So we have a method called start method. So whenever you call the start method, the run method will be called. Okay, so the same example, whatever we discussed, now we'll see with a program example. Okay. So first what I'm doing is I'm creating one bus. I'm creating a class with a name called bus. Then I'm creating a method called book ticket is a method. Okay. I created a class called bus, and this bus class I'm creating a method called book ticket. To book the ticket, we need to pass few input parameters. One is the seat number, and what is the name, what is the gender. Okay, so here just I'm printing some statements, system.out.println. And one more thing also will pass the vendor, whether you are booking a ticket through Abibus or Redbus. That vendor name also I want to print. Okay, so system.out.println. So dear, then I want to print the name of the person. Okay, so your seat is confirmed. Then I want to print the seat number. Your seat is booked, for example, through. So I want to print the vendor name. I want to print. Okay, so we created a class called bus class. In that bus class, we created a method called book ticket method, which is taking 4 parameters as an input, and just we are printing those parameters. So for example, if I pass dear Mahesh is a name, so dear Mahesh, your seat is booked, and it will print the seat number and through what is a vendor, whether it's Abibus or Redbus. So let's save the class. I'm saving this class. The name bus.java. Next. So we are done this class we created. Okay. And just to demonstrate this example, first I created a bus class I created. Then we need these two threads, right? So we need to create 2 separate threads we need to create. One is Abibus, another one is Redbus. So I told you how to create a thread. Just create a class and give me this class name called Abibus extends thread. Okay, let's save this class name. Abibus. Okay, so in this Abibus class, you need to override the run method. We need to override. Okay, we need to override what? The run method we need to override, because it's a thread, right? So thread, whenever you start the thread, it automatically will call the run method will call automatically. So let's override the run method. So public void run. Okay, let's save it. So we forgot to specify .java extension. That's why it's saved as a text file. Okay. So run method. So whenever you start the thread, this run method will be called. Okay. So inside the run method, inside this run method, we want to call this book ticket method. We want to call. Okay. That's what our requirement is. Inside from this thread, Abibus thread, we want to call this book ticket method. But so to call that book ticket method, we need this bus object is required. That's why what I'm doing is here I'm creating a constructor. Constructor is a special named block with the class name, right? So if you create a block with the class name, that is called as constructor. So this constructor, which is taking the bus object as an input, but you know that the scope of this variable is within the block, because this is called as a local variable. The scope is within this block. We cannot access outside the block. So that's why what I'm doing is I'm creating one instance variable. Okay. Now assign this local variable into instance variable. So whenever you call this dot the variable name, it's going to search in the class level. Okay. So this refers to the instance variable, not a local variable. So I called this dot bus is equals to bus. So we are assigning the local variable into what? The instance variable. Okay. So we got the bus object now. So now we can call inside the run method bus dot call this method. What is the method name? Book ticket is a method. Let's call this book ticket method. Okay. So as in that I'm trying to book the ticket, a seat number 15. The name is Mahesh. Okay. So what is the gender? Given male is a gender. Okay. What is the vendor? I'm giving the vendor name as Avivas. Okay. So we created this Avivas thread we created. Okay. Next we need to create the red bus thread also we need to create. Okay, to demonstrate this synchronized access modifier concept. So what I'm doing is same logic, just we need to make some class names. Okay, change the class name. So I copied the whole code, whatever written. Let's create a new file. Save it. So I'm changing the Avivas to red bus. Change the constructor name red bus, and here also red bus. So save this file with the name redbus.java. Okay, so now we created these two separate threads we created, and we created the bus class also we created. Now to start these two threads, because directly we cannot start these threads and we cannot load these threads into stack for execution directly. Okay, so to load this two threads and to create an object for this bus class and to demonstrate this, first we need a main method to run this program, right? So main method, whenever you run this main method, it means it's going to create a main thread. That main thread will be loaded into stack for execution first. Okay, so that's why what I'm doing is, for testing purpose, I'm creating another class. I'm creating test. Let's save the class name test.java. Okay, now whenever you run this program, whenever you run this Java test.java test class, whenever you run this program, so this main thread will be loaded into stack for execution, right? So this main thread will be loaded into stack for execution first. So first what I want to do is I want to create the object. Just now we created a bus class and we created threads. Okay, so as of now it's empty. Your JVM, whenever you run this program now, first what will happen is it's going to load, the main method will be loaded into stack for execution first. Okay, so whenever you run this program now, okay, what will happen is the main thread will create. So where that main thread will create? Inside the stack. Okay, so now first what we want to do is, in the heap we want to create this bus object we want to create first. So as of now we don't have this synchronized access modifier also, we have not applied this. Okay, so book ticket is a method. So first I want to create this object I want to create. So how will create an object? How will create an object in Java? So one of the method to create an object is by using the new keyword, right? So new bus. So an object will create. Where the object will be created is inside the heap. The object will create. Okay. So now this object will create inside the heap. Okay. But we had to specify some reference. Okay. So that's why what I'm doing is here, specifying bus b is equals to new bus. Okay, so we created the bus object we created, and B is the reference. So now inside the main thread, we specified a reference for this object bus. B is the reference we specified. So now for this object, what is the reference is? B is a reference, or you can say it's a variable. Okay, so which is holding the address of this bus object. So B is a reference name which is holding the address of this bus object. So whenever you run this program, so this is what will happen now. So the main thread will be load first. Inside the main thread, we created the bus object we created, and B is a reference. So what is the next thing we want to do? To demonstrate this, we want to create two separate threads we want to create, right? So we want to create two separate threads we want to create. So one thread name, we already created the threads already. So we already created these threads, the bus thread, and with these classes we created. So now we want to start these threads we want to start. So let's create the object for this AbiBus class and RedBus class and call the start method. But to create an object, we need to pass this object, we need to pass as an input, right? So after creating the bus object, so now we'll create the objects for these two threads is equals to new AbiBus and pass the bus object as an input. And how we'll start the thread? Call ab.start. So whenever you call this start method and we are passing this bus object as an input for this constructor to create an object. So whenever you call the start method, the thread will be load into stack for execution. The thread will be load into stack for execution, right? So what is this thread name is? AbiBus. So assume it is one thread. And this thread class contains a method called what? What is the method name? Run method. So this run method will be called. So inside the run method, what we are doing is we are calling the book ticket method. We are calling inside this run method. We are calling the book ticket method. We are calling. Okay. Next. So whenever you call the start method, this thread will be loaded into stack for execution. So meaning the run method will be called, and from the run method we are calling this book ticket method we are calling. Okay. In a same way, we want to start the second thread also. We want to start. Let's take a RedBus. Pass this bus object as an input. rb.start. So now whenever you call the RedBus.start, what will happen? Now the second thread also will be loaded into stack for execution. So now the second thread also will be loaded into stack for execution now. The second thread also will be loaded into stack for execution. So now the both threads are calling what? The book ticket method. So let's compile and run this program and see the output. Java C. First, okay, we are all check the location. We are already inside the Java examples folder. So if it is not, just write cd and specify the location where you save the Java files. Okay, so Java C test.java. So there is no any errors. Then Java test. So you can see the output. So first main thread is called first. So from the main thread we are starting these two threads. We are starting AbiBus and RedBus. So that's why you can see the first statement, because first thread is called now. Dear Mahesh, your seat is booked number 15 through RedBus, and dear Mahesh, your seat is booked number 15 through AbiBus. So the both threads are executed, correct or not? Because we got the output for RedBus and we got the output for AbiBus. So it means the both threads are called this book ticket method. Okay. to make it more clear, what I'm doing is here, which thread is calling this book ticket method, that thread I want to wait for some time. So I'm calling here thread.sleep for 100 milliseconds or 1 second. Okay, so which thread is calling this method, the book ticket method, that thread will wait for 1 second. Okay, so this sleep method is going to give an exception. So that's why what I'm doing is, so handle the exception using try catch. Okay, so just to make it understand, what I'm doing is, so which thread is calling this book ticket method, that thread I'm putting into a sleep state. So we specified a time 1 second. So that particular thread will enter into a sleep state. So for 1 second. Okay, let's see this. And this book ticket method I want to repeat for 10 times. So all this I'm doing to to make it understand. So we'll call this book ticket method for 10 times. We'll call. And inside the, and don't forget to save whenever you make some changes. And even this, after from the thread 2 or red bus also, we want to call this one for 10 times. We want to call it. Save it. So compile and run. Java test. Now you can see 10 times it's going to print these statements because the loop is going to repeat for 10 times, and you can see some delay because we specified thread.sleep 1000, right? So for every time, every time it's going to, for every iteration, it's going to wait for 1 second. That's why you can see both threads are executing, but both threads are, in a holding state. So whenever which thread is calling that book ticket method, that particular thread is in a waiting state. So that's why you can see the output here. The both threads are executing now. Your seat is booked through Abibus, red bus, Abibus, red bus, Abibus, red bus, Abibus, red bus, like that. Okay, so now my requirement is, I don't want to call this method from multiple threads, because the real time you'll get some issues you will get if you call this method from multiple threads, especially when you're developing this booking or reservation system applications, or when you're working on the banking transaction related applications. So you'll get some conflicts we'll get if multiple threads are calling that same object method at a time. So we want to restrict. I don't want to allow the multiple threads to call this method, the object method, at the same time. So what we will do is, so we'll make that method as a thread safe method by applying the synchronized access modifier. Save it. Okay. So now let's see the output now. See, remember, this is the earlier output we got. So both threads are executing that method, calling that method. But now I applied the synchronized access modifier. I applied this method. So what will happen is, which thread is called that method, and we don't know that which thread is going to call. Either Abibus can call or Redbus can call. Okay, so which thread is called that method? So that for that particular thread, we want to acquire a lock. So until it complete the execution. So then after that, so then only the next thread can call. Okay, so let's see here now output Java C test.java Java test. So you can see first the lock is acquired for Abibus. But this output also wrong, because first Abibus is triggered, then after that Redbus is triggered. It's the wrong output, because once if it is lock is required for Abibus, it should not call for red bus. Maybe the file is not saved, I think. So let me save it again. Okay. We compile this Java C bus.java, Java C test.java, Java test. Sorry. So we'll call only one time, we'll call this method, because what is happening here is first time the Abibus is called the method book ticket method. Then after that, if red bus is trying to access, it is in a waiting state. So to make it clear, we'll call only one time only, we'll call this method book ticket. Okay, so we'll repeat this loop inside this book ticket method. Here we'll repeat the loop. Let's save it. Okay, first we'll see the output without synchronized. So what I can do is, just for save the time in the classroom, I can prepare these classes before and I can show it directly in the classroom, but that is not my teaching style. So I want to write everything in the everything while recording the session, and you also will understand what is the problems we are facing, and you also will understand how to resolve the issues. That's why I prefer to type the programs in the while I'm recording the session itself. Okay, so let me recompile these two classes again. First, I have not applied the synchronized. Now let's see what will happen. Java C test.java and Java test. So you can see both threads are calling. So November 15 through Abibus, through Redbus, through Abibus and through Redbus. So both threads are calling the book ticket method, right? The both threads are calling the book ticket method now. Both threads are calling the book ticket method. Okay, inside the book ticket method, which thread is calling that particular thread, we are putting into sleep state for 1 second. But if you see the output here, both threads are calling this method through Redbus, through Abibus, through Redbus, through Abibus. How much time we specified? Count 10, right? Yeah, why it's not ending is because we removed this for loop statement, we removed in these classes. Then after that we have not recompiled. That's why it's repeating continuously. So now we'll recompile all these classes. Let's see the output now. So Java C, recompile all these classes, or you can put start.java. So all the classes will compile. So whatever the classes we created, so I created the 4 classes, right? So all that 4 classes will compile at a time. Okay, I don't have any other classes, that's why I'm using that start.java. Okay, but when you're doing in your machine, so how many classes are there in that particular folder, all the classes will compile. Okay, so Java, I want to run this test. So you can see November 15 through red bus, through AV bus, through red bus, and through AV bus. So how many times it's going to print is 20 times. So 10 times for AV bus and 10 times for red bus. Okay. So now what I'm doing is I will apply this book ticket method with the synchronized access modifier. Synchronized access modifier. Now you can see Java test. So first lock is acquired for AV bus now. So even now red bus is trying to call that book ticket function, but the method is synchronized method. So lock is acquired for the AV bus. So it will be in a waiting state. See, after execution of this thread 1, now you can see the second thread is called, meaning until that this second thread is in a waiting state. After completion of that first thread, then only the second thread is called. So because now we applied the method with the synchronized access modifier. So hope you got an idea of what is synchronized access modifier, why we need the synchronized access modifier. Okay, so same like synchronized methods, we have a synchronized block also. Okay, so here inside this method, what I want to do is I want to print a welcome message. For example, system.out.println. So it's a message I want to print. So welcome to Road Transport Authority, something like RTA India, for example. So this message I want to print. So which thread is calling this book ticket method? Okay. So for that thread, I want to print a message, welcome to RTA. This I want to print. So now let's see here. Let's compile. Java test. So first now you will get welcome to RTA message. See, welcome to RTA India. So then after that, the lock is acquired for AV bus. Okay. So the AV bus thread is calling that method. Then after that, you can see welcome to RTA message again, meaning the first thread is release the lock. After first thread is release the lock, now the second thread is acquired the lock. Okay, but now my requirement is for this to print the welcome message, I don't want to wait the second thread. I don't want to wait the second thread to print the message. This is not a business logic, just it's a welcome message, to print a welcome message. So some particular lines of code inside the method only I want to, when the thread is accessing some particular lines of code inside the method, at that particular time only I want to acquire a lock. Okay, I'm repeating again. I don't want to acquire the lock when accessing the method. I want to acquire a lock when thread is accessing some lines of code inside the method. So for that requirement, we used synchronized block we use. So now what we'll do is, I'm removing this synchronized modifier for a method. Okay. Before that, first, I'll write this statement. Synchronized block. So synchronized block we use inside the method. Okay. So here return type, method name, some input params. Okay. Statement 1, statement 2, like that you can write multiple statements. My requirement is when thread is accessing some particular lines of code, at that time I want to acquire the synchronized, at that time I want to acquire a lock. So you can use, at that time you can use a synchronized block. Just put synchronized and opening and closing bracket. So when thread is accessing the statement 2, at that time only the lock will acquire. When thread is accessing the statement 1, it will not acquire a lock. Okay, this is the synchronized block. So here I'm removing the synchronized access modifier for the entire method. Okay, only when thread is accessing this particular logic, at the time only I want to acquire a lock. So we can call synchronized. Okay, so just what I'm doing is here to make it clear, I'm printing the vendor name also. Okay, so let's compile. We made some changes in the bus class and synchronized. Sorry. So synchronized after that, so then we need to specify this. Okay, so this means the thread will, okay, so synchronized of this. So this is synchronized block now. So we are applying the we are acquiring a lock when thread is accessing the some particular statements inside a method, not for whole method. Okay, so let me recompile this. So you can see the welcome to RTA message is printed 2 times now. So meaning when for printing the welcome statement, the lock is not acquired. The 2 threads are able to access this statement. But when the first thread is accessing these particular lines of code, at that time the lock is acquired. The second thread, if try to access, it will be in a waiting state. So that's why after completion of this abhi statements, you can see the red bus statements. Okay, so hope you got some idea about the synchronized access modifier. Okay, and what is the purpose of the synchronized access modifier and the synchronized block. Okay, so please subscribe to my channel if you want to get more technology videos like this. Thank you.